Okay, some more people are showing up, so let's go ahead and let's look at typing out a solution to exam 1. All right, so here's the problem. Okay, so let me just move this over here. Okay, so I'm going to go to my exam 1 section and then say begin problem. And then the problem states show the negation of P. So, okay, show, let me just, so I don't type LaTeX with, I don't type a lot of logic problems in LaTeX. So I'm lost. I don't know what these symbols are. So what I can do is say, okay, let me go over here and just say logic symbols LaTeX. Search in Google. So I see the negation, L not, or NEG. So I'm gonna go back over here, NEG. I'm gonna run that. So I see the not symbol. Okay, that's good. So I'm going to bracket there. So I'm going to say, okay, show that negation of P. And then, so and, what is and? I think it's land for that symbol. So, and P or Q, I'm just guessing. Close that bracket, so let's see if that works. It did. Okay, so that implies, or a right arrow, Q. And then what is logically equivalent? This right here. I can literally just copy that, come over here, and then capital T. Run that. Okay. All right. All right, so I don't like how close these problems are currently together. In proof, and then I think it's V space. Maybe I'll put in like 5 millimeters or something. Now I get a little bit of space now. Okay, so how can we show this to be true? This is a tautology. There's several ways to do this. Let's see if we can do it. I guess personally, I would do this with words, but I want to show you how to string together logical equivalencies. So let's go ahead and start on the left-hand side. So put that in there. Okay, so I sort of don't like how this is lining up because I'm going to want to stack logical equivalencies, kind of like I'm stacking here. So maybe what I can do is I can go down here and copy paste this. Come over here, paste that, and then I'm just going to take this guy here, copy that, put it there. And then instead of an equal sign here, I'm going to put equal. Just compile that, see what that looks like. Seems to be Oh, just got these mixed up. Okay, so now I can just get rid of this up here. All right, so let's get rid of that. All right, so what is this equivalent to? Well, I'm going to use star, so it is not that or Q. So I'm going to say, just to save time, copy, so I'm going to say any G, paste that in. I need some more space here. And then or Q. Okay, and so what was the law that we used there? So whenever you're going to put in text, you need to, while you're in math type, you need to go ahead and specify that. So you can say text space by star or something. And maybe you might want to put like several. Notice that didn't put any spaces. So maybe what we can do is we can look up, okay, space. So maybe quad, this right here. So go up here. So instead of doing, I can just do that, and right before that, put that quad and see what it does. And you see that it did indeed put some more space there. Maybe if I put like another one, let's see what that does. Okay, so that looks like the, right here, that looks like the correct rule. All right, so now we need to use De Morgan's law and send this in. All right, so this is now an equivalence instead of an equation. And this is going to look kind of messy at first. So this will be NEG of NEG of P, and then lor NEG of P lor Q. K lor Q. And then do that quad thing again, and then text by the more. All right. So then we can use double negation right here. So this is going to be, I can literally just like copy this here, put it right there. And now this is just going to be P. And that was by double negation. Okay, run that. Oh, I don't like how these are not lining up, but I do know that with this little, with these ands, we can separate things. So what if I do a little and right there, do an and right there, and do an and right there? Does that give me an error? It won't fit it, but let me get rid of the quads and see what happens. The ands, by the way, they just like, they try to line up. I'm just getting rid of the ands now. I don't like how it turned out to be. I don't need this extra quad though. Okay. Oh, maybe I do. If I put that other one there, these now line up. They do, sort of. So maybe I can put another one here. Maybe one more. Now they're not quite lining up. So if I look at spacing, oh, there's like a double Q. You see that? That makes it go a little bit further. So I'm just playing around with it right now. So I'll just put like a double Q there. And I put maybe like a double Q there. Again, I'm just like playing around with it and looking up on Google. And just trying my best to get it aligned. You know, there's going to be better ways to do this. I'm just doing this the fastest way possible right now. So they're getting there. All right, so I need a new one. And then N. Oh, that should just be P. All right, this double negation from there to there. Okay. So we just look up. Make sure. Oh no, it's the associate. So I'm just looking up things to suppose you didn't know. And as you're doing this, you could say this is by associativity. So the next line, I'm going to group these things together. I'm going to copy that, paste it, and I'm going to say P or Q inside of there. And then I can get rid of this one right here. I'm not. Okay, so if I go back here, get rid of that, trying to line these things up. Okay. So getting there. And this is like P, this is like R or not R. So this is going to be true. And you can put like a comma there, and then get out of here. Here, the last line follows since R or not R, when you G R, is with true for all propositions, and that would end the proof. Okay, so that would be problem 1. And then if I just say, you would do a similar thing for this problem. Did I already prove this one? Problem. This is basically very similar to how I typed up this one. This, by the way, is false. For those of you with me, why is this false? Which I told you I would do, by the way, that I'd give you some statements that might not be true. Why is this statement false? There's only 4 of you. So here, suppose x is 0. That's a rational number. And suppose y is pi. 0 minus pi is equal to negative pi, which is irrational. So that's a counterexample, right? Prove the square of a number is odd if and only if the original number is odd. That's basically what I did here with this problem, just this is the even version of it. Okay. And that was it for exam 1. So if I go and content, exam 2. Okay, let's look at this. You can string together sets just like you can here. Just like we had logical equivalencies or equation equivalencies, you can have set equivalencies. But maybe we'll go ahead and look at this, right? So A intersect B minus A is going to be said. Okay, so going down to section 2. Begin problem. Prove the following. If A and B are sets, then A cap, if you looked up the intersection symbol, you'd see that it's cap. A intersect B minus A. B minus A is equal to the empty set. Okay, so then maybe I'm going to put some like space down here. B space 5 millimeters. And put my proof right here. Begin proof. And proof. I like to space these things out a little bit. All right, so what does that look like? All right, so this we can prove by way of contradiction. Just assume that there's an element in there, and then you get that that can't happen. So we can say by way of contradiction, suppose A intersects B minus A not equal the empty set. All right, so then by definition, there has to exist an element in there, right? So then there is at least one element x slash n a intersect a minus b. All right. And by definition, x is in a and x is in a minus b. Okay. Okay, so, oh no, b minus a, I'm sorry. B minus a. Okay, so let's run that again. All right. So again, by definition, if x is in b minus a, then x is in b and x not in a. So then we can say, however, x is in a and x not in a is impossible and thus we have a contradiction. Done. Okay. That's just one of many ways to prove that. A lot of you didn't have too many problems with those set proofs. For example, I think almost all of you got this correct. Because if you just pick an element in x intersect b intersect c, then x is in a and x is in b and x is in c, and in particular, x is in a. So anything you pick over here has to also be in a. Okay. I did this one already. Did this one. Did this one. Didn't do this one. This is similar to this one. Okay. So are you? I want some feedback from you while I have you in class. Are you getting used to working with LaTeX? I know it's kind of slow at first, but with time it does become a little bit easier. But are you at least like beginning to get the hang of it right now?
Yeah, I think the problem is more not the problem, but more of a difficulty thing is trying to find the how to write out the symbols and making sure that they're lined up. So that was pretty much the problem I had, and I'm still kind of like trying to work through it.
Um, yes, so again, like searching on Google, just aligning equations in LaTeX will just copy paste and modify what they have. That's kind of what I did in the last lecture that I held. Hopefully that helped a little bit. Um, and even if like you're having a hard time like aligning the equations, you can always do it sentence by sentence, like this equation here, period, this implies this next equation, period, which implies this next equation, period. So you can have workarounds if you try to get creative with how you put together the argument.
Okay, thank you.
Anything else? Any other comments on learning LaTeX?
This isn't necessarily latex, but I think I asked you over email about the exam one overview that you were gonna do.
Oh, the solutions to it?
Yeah.
Okay, so let me quickly pull up something. Hold on, I'm looking at my screen right now. Which question in particular are you thinking of from the first exam? Let me share my screen so you can see what I'm looking at here. So I just did this solution. Um, this one's very similar to one that I did, and a lot of you did well on this one as well. This you prove by contrapositive. You assume that n is odd, and then you show that 11n times 11n plus 2 is odd. This one I told you is false, and I gave you the counterexample, or one counterexample. And then here, this is very, very similar to the solution that I wrote up in last lecture. Where is it? This one. If n is an even integer, if and only if n squared is even. This same proof, just replace 2k by 2k plus 1, and you get precisely uh, the solution to this. But which one of these problems are you thinking in particular that you really wanted to see the solution so I can just address it right now? For example, how hard is this one?
That one isn't that hard.
Okay. And then this one's false. And you just provide a counterexample. For example, x is 0 and y is any irrational number, then x minus y is going to be irrational. What about this one? How hard is this one?
I think that one I did right. But yeah, I'm sorry. I think it was more of exam two than exam one that I wanted to look over at.
Okay. Okay. Well, so I gave the solution to this one. So the solutions for 2 and 8 and 6 have been posted, but I can film a whole thing on exam 2. I didn't know you were asking about that one as well. So I'll go ahead and I'll do that later this afternoon. Any other questions? Do you
I
hate
actually
LaTeX?
had a question.
Yeah.
For the number 4 from the exam, I was a little confused on like when we say, because you said it was false. Do we just like put like let one be something and then let the other one? So then is that all we have to put, or is there like more to it
Yeah, that's
as
the
far as
way
like formally writing it?
So if x is rational, and y is irrational, so this is a statement, then x minus y is rational. And then you would say something like this, like false. For a counterexample, take x equals to 0 and y equals to pi or something. Then x minus y is equal to negative pi, which is not rational, or something like that. So if the statement is false, you just need to provide examples, like choosing X and Y or choosing a given, yeah, just choosing examples that show that the statement is false.
Thank you.
Mhm. Anything else?
Did you say that you were gonna put like extra bonus questions on the
Yeah,
final?
I haven't picked those out yet, but they're going to be from real analysis topics. You don't have to answer them, but I'm going to provide them probably this weekend. And if you choose to answer them, they won't hurt you if you get them wrong, but if you get them right, then they can give like 5 points per bonus problem that you solve.
Okay, thank you.
Mhm. All right, well, I guess that'll be it for today. I'll put some exam 2 solutions for ones I haven't solved yet so that you can see them, and then start typing those in and putting together a nice little document that shows uh, all of these solutions. All right,
Thank you, Professor. Hope you have a good day.
you too. Y'all stay safe.